squared is equal to 2x squared plus 2y squared minus x. The whole thing on the right side is squared. And we're given a point, which is the point 0, 1/2. And then they give us a picture of this curve, which is just fun. It's not absolutely required to have the picture, but here it is. So here is the picture of this curve right up here. So this is our cardioid. And so when you took your trig class, it's possible that you saw a shape like this when you talked a little, maybe if you talked a little bit about polar coordinates in that class, then this shape might look familiar. The equation up here is the algebraic version of the polar coordinates for this graph. Okay. All right, now our job is to come up with the equation of the tangent line at our given point. So find the equation of the tangent line at 0, 1/2. So x is equal to 0, y is equal to 1/2. So we're looking at this point on the y-axis right here. And so eventually we're going to find the equation of a line that's going to look roughly like this. Okay, so in order to do this, to come up with the equation of the tangent line, we need a point and we need a slope. Now the point is given to us, so we just need a slope. And our slope will come from calculating dy over dx at our point 0, 1/2. All right, so to get that, we're going to need to look at our equation. So we've got x squared plus y squared is equal to 2x squared plus 2y squared minus x, the whole thing squared. All right. So so Andrew, is your question going to come out of finding this derivative here?
Yes.
Okay, great. Okay, so when I want to implicitly differentiate this thing, I want to think about x is my variable, y is going to be a function of x. And so I might start by rewriting this as x squared plus f of x, quantity squared, is equal to 2x squared plus 2 times f of x squared minus x, whole thing squared. Okay. Now, differentiating on this left side, I'm going to take my derivative with respect to x all the way across. So my derivative of x squared is just 2x. But now when I take the derivative of f of x squared, I'm going to have to use the chain rule on this. So the chain rule says take the derivative of the outside, keeping the inside the same. So we have 2 times f of x times the derivative of the inside. Now my inside is f of x, so its derivative is f prime of x. So this is what my left side looks like. Are there any questions on taking the derivative on the left side? Okay. So now we're going to move on to the right side. And life is going to be, yes?
We can use y prime, can't we?
Absolutely.
Okay.
So in my opinion, I like to rewrite this because then I can identify my chain rule. Once I get used to that idea of the chain rule, then I can leave this as 2y times y prime. Absolutely. Okay, so other questions before I go to the right side? All right, so on this right side over here, I've got a couple of things going on. My biggest set of parentheses is all of this stuff squared. So I have x squared for my outside function. So I'm going to take derivative of the outside, bring that 2 down in front, keeping the inside the same. 2x squared plus 2 times f of x squared minus x, all of that raised to the first power, times the derivative of the inside stuff. So now when I look at the derivative of the inside, Well, I've got three separate terms that I'm going to have to deal with here. So the first one, 2x squared, its derivative is 4x. Plus, okay, my second term, I've got 2 times f of x squared. I'm going to have to apply the chain rule here, so I bring that 2 down in front. And I've got 4 times f of x, so derivative of the outside, keeping the inside the same, times the derivative of the inside, so times f prime of x. And now I can move on to my last term. Derivative of x is 1, so I have minus 1. All right. We have now finished with the calculus part of taking the derivative of the entire equation. Are there any questions about writing that down? Okay, so now I want to go and I'd like to now solve this for f prime of x. And one thing that I like to write my y's as f of x when I'm taking my derivatives so that I can see my chain rule in full action. But when I want to solve now for f prime, my notation is easier if I use y rather than f of x. So I'm going to start by rewriting this as 2x plus 2y dy over dx is equal to, now over here I've got 2 times 2x squared plus 2y squared minus x times 4x plus 4y dy over dx minus 1. All right, now my goal is to solve this entire expression for dy over dx. So on the left side, I have one term that involves a dy over dx. On the right side, all of this stuff is multiplied together, and embedded in the middle of that product is this dy dx, which means that I need to expand all of this out. All right, so maybe the first thing I'll do is to multiply this 2 through everything. And so I'll take the 2 and distribute it to everything in my first set of parentheses. Notice I'm only doing it in the first set because it's 3 things that are multiplied together. So I've got 4x squared plus 4y squared minus 2x. All of that times 4x plus 4y dy over dx minus 1. And my left side is still 2x plus 2y dy over dx. All right, my next job is to distribute 4x squared plus 4y squared minus 2x to each of these terms over here on the right side of the parentheses. All right, so here we go. On our left side, we have 2x plus 2y times dy over dx. And on the right side, I'm going to multiply this 4x squared through. So 4x squared times 4x is 16x cubed. 4x squared times 4y dy dx is 16 x squared y dy over dx. And then I'm going to take out 4x squared times a negative 1. So we have minus 4x squared. Okay, first term done. Now we'll go into our second term, 4y squared times 4x. So we have plus 16xy squared. 4y squared times 4y dy dx. Plus 16y cubed dy over dx. And then minus 4y squared. Okay, so we've taken care of our first 2 terms. And now our last term, negative 2x times 4x is negative 8x squared. Thank you. Glad you're here. So negative 8x squared minus 8xy dy over dx. And then plus 2x. 2x. Whew. All right. So we've now written out that entire right side. Are there any questions about what we've done so far? Jeff?
Not what we've done, but do we need to do that?
Good question. Do we need to do it? What are your thoughts on that?
Yes.
No. Go ahead.
All right. Well, so that's a good question. Do we need to do this? And so if our goal is to come up with an expression for dy over dx in terms of x and y, then yes, we do need to do this because now once we have everything multiplied out, then we can collect all of the terms together, all the terms that have a dy dx. There's 3 of them. No, I'm sorry, there's 4 of them. Those 4 terms will all go on one side, and every term without dy dx will go on the other side. And so if that's our goal, if our goal is to find dy over dx is equal to stuff in terms of x's and y's, then this is what we have to do.
Okay, since this is 0 and 1/2, could you just
So now,
substitute 0 in there?
so
for
at
x
this
some
point, if
before-
what we're doing in this particular example, we only want to know the slope at specifically 0 and 1/2. We can go to this step and we can plug in 0 for x and 1/2 for y, and we can solve for dy dx after we've plugged those numbers in. So in that case, we could do that right away. Okay, so that would absolutely be fine. I'm going to keep going with this one
Right,
because it's
yeah.
going to give us a slope at
Okay.
any point that we want on here, and that'll be useful if we have more than one point. But you're right, because we're looking at specific points 0, 1/2, we can plug in those values here and solve for dy dx, and it might make the algebra a little bit easier. Good. Okay, so here we go. Our algebra is exploded as far as it's going to go. We're going to regroup now. Move everything involving dy dx's to the left side. So we've got 2y dy over dx minus 16x squared y dy over dx minus 16y cubed dy over dx plus 8xy dy over dx is equal to 16x cubed minus 4x squared plus 16xy squared minus 4y squared minus 8x squared plus 2x. And then we're going to subtract this 2x off from the other side. So minus 2x. And so those two terms are going to cancel each other. All right. So we've now regrouped everything. Everything involving a dy dx is on one side of the equation. Everything without a dy dx is on the other side. And the reason we want to do that is now we can factor out the dy dx. So on the left side, I've got dy over dx is equal to, or I'm sorry, dy over dx times 2y minus 16x squared y minus 16y cubed plus 8xy. And on the right side, I can copy everything down.
Can you combine the 4x squared and the 8x squared? Yeah.
Yes, that would be a really good idea. So those two together give us negative 12x squared. So we've got, on the right side, 16x cubed minus 12x squared plus 16xy squared minus 4y squared, and everything else is combined. All right, life is getting better. All right, what's our very last step here? Yeah, we want to divide. We want to take this whole honking thing over here on the left side and divide the left side by that, and also divide the right side by that. So divide by this piece, little quotes on that, and divide by the same. So in the end, our dy over dx is going to be, because on the left side these big pieces are going to cancel. And on the right side, we'll be left with 16x cubed minus 12x squared plus 16xy squared minus 4y squared. All over 2y minus 16x squared y minus 16y cubed plus 8xy. And this expression, although extremely large and has a lot of letters and numbers in it, this expression is pretty cool because what it does is it tells us that for any point on this curve, if we know the ordered pair xy of that point, we can plug that x and y in and figure out the slope of the tangent line at that point. So on this example, our next step would be to figure out the slope, dy over dx, when x is equal to 0 and y is equal to 1/2. All right, so I'm going to leave our picture up here. And so our slope is our derivative at 0, 1/2. So let's see here. We've got 16 times, oh, I love zeros. Zeros are fabulous. All right, so we have 0 minus, 0, plus, 0, and then minus 4y squared, so minus 4 times 1/2 squared. And in the denominator, we have 2 times 1/2.
Minus
0. And then minus 16 times 1/2 cubed plus 0. All those zeros. That's so nice. Okay, so on the top here, we've got 4 times 1/4, which gives us 1. So we have a negative 1 on the top. On the bottom, we've got 1. 1/2 cubed is 1/8. So this becomes minus 2. And so we have negative 1 over negative 1, which means that after all of that work, the slope of this diagonal line right here is a slope of 1. All right. At least it wasn't 0. That would have been even more disappointing than doing all of that work for a 0. Okay, so now we have our slope and we have our point. Are there any questions on coming up with those two values? So I think Jeff's suggestion of plugging in 0 for x and 1/2 for y at this line right here might have made this algebra a lot quicker because we would have been working with numbers instead of symbols, and a lot of stuff would have gone away because of the x equal to 0. But we would not have had a slope for any xy value. So this actually gives us more information if we want to continue this problem for other points on our curve.
Wouldn't it be the same if you plugged in the 2 numbers on that side?
Over here?
Yeah, like if all of a sudden you give it a different set, you could do the same thing with that first equation, right?
Right, absolutely. I could take this and then I could say, okay, and then I would still have to resolve that with those new numbers as well. So, but you're right. I mean, it would still be
Because I mean, if you're not resolving that one, you still got to resolve this one.
right.
Unless you have big numbers.
Yeah, I mean, if your numbers here are really ugly, this could still be just as much work as doing it symbolically. So, yeah. It's kind of 6 of one or half dozen of the other. Depends on which you prefer. All right, so to wrap up this problem, we've got our slope, we've got our point, and so our equation of the tangent line, well, I can use y minus y1 is equal to slope times x minus x1. And so we've got y minus 1/2 is equal to 1 times x minus 0. And so all of this work that we've done comes down to y minus 1/2 is equal to x, and we'll add 1/2 to both sides, so we have y is equal to x plus 1/2. All right, Are there any questions? This is our final answer on this particular problem. Okay, the equation of this tangent line that we have drawn. All right, Andrew, does that answer your question?